Welcome, students, to another video lecture with Mr. Kinnett here. You're going to want to pause here and copy down what you see, but just a quick explanation before you do that. On this right side here, what this lesson really is focused on is teaching you how like an architect would draw a picture or an artist could use a model before they actually create the larger picture or the larger building that they're building. Turns out that it's really hard to find paper that may be 10 feet by 30 feet big, and that sometimes you just want to do a scale model before putting the mural up on a wall, or like an architect would do architectural drawings on paper. But again, it's hard to find paper the size of a house. So go ahead and pause and copy down what you see here, and I will give you the lesson in a moment here. Okay, welcome back, students. So this lesson is about how to use scale drawings and models. And our essential question is, how are scale and scale factors alike, and how are they different? So scale drawings and models. So these are used to represent an object that is too large or too small to be drawn or built at actual size. Like I said, similar to an artist making one of those really large building murals, or similar to an architect making like architectural drawings for a building or a home. So I have this wonderful, wonderful drawing. My skills keep on getting better every day. This mural is an example of a model of a smiley face that some artists wanted to place on a 10-foot by 30-foot building. And I know it would have been so hard, they had to practice a lot. But they had needed some smaller paper to practice on, so they practiced on paper that was 12-inch by 36-inch. And it turns out that this can be done to help us scale up. And we're going to recycle the skill of cross products, or a ratio set equal to another, and cross multiplication. So get you the next few slides here. You go ahead and pause and copy down what you see. Okay, so this is an example of someone trying to make a blueprint for a skateboard ramp they're building at their house. And we are going to create a proportion that's a ratio set equal to another ratio so that we can solve using cross products for this missing dimension, this missing unit we need to know. So in this problem, we're going to learn that the skateboard ramp shows that its length is 11.4 inches. And on the blueprint, it's going to have 1 inch is 6 feet. So realize this is not telling you that an inch equals 6 feet. It means in their scale drawing, 1 inch equals 6 feet. So this is not like a universal conversion we were memorizing before. And sometimes it helps me if I draw my picture here. So here is my ability to draw a skateboard ramp. And we'll just make it more fun and add a guy or lady skateboarding. I know, it kind of looks more like they're falling off the side, but I'm practicing my drawing every single day. What it says is in our model, we know that the base of this model we've been drawing is 11.4 inches. And what we're trying to figure out is how long we'd actually have to build the actual skateboard's ramp. So what is the length of the actual ramp? So boxing my question here, and we're looking for this length of the actual ramp. And the key on this is that universal rule of math to be fair. And what that means is, just like in our solving proportion lesson, it doesn't matter which units I put on the top or which units I put on the bottom. It just matters that I'm fair and I do the same thing on the left side's ratio as I would to the right side's ratio. I'm going to need a little space to actually do this problem, I think. So in this case of being fair, we want to make sure that we put the model's dimensions on the top or on the bottom, but we're being fair. So I'm just going to go ahead and say we're going to put the model on the numerator and the actual will be on the denominator. Okay, so we're going to remain consistent. We're going to be fair. So I need to create a proportion. So that's a ratio set equal to another ratio. And we know that the length of the model is 11.4 inches. And I'm just going to circle how we know that one more time. It says the length is 11.4 inches in our blueprint, aka the model. Okay, so I'm going to place the 11.4 inches on the top. Now we have to go look at that conversion part of the problem, this 1" equal to 6 feet. Which one of these numbers represents the blueprint? Yeah, you're right, it's the 1". The 1" is the blueprint. And which number in this conversion represents the actual skateboard ramp? Yeah, it's 6 feet, so we have to put it below there. Okay, and we do not actually know how long our skateboard ramp needs to actually be in length. So since that is an unknown number, that means that's the location of the variable. And what unit are we going to need on this variable? If we have inches for the model, and then on the right side here we have feet for the actual ramp, what unit has to be on this side also? Yeah, you're right. It's feet. And we want that there just in case we forget in our answer. As long as we get it there to start, we'll be okay. Okay, so if you're having trouble on solving proportions, please re-look at your 5.7 note, because we're going to recycle that skill of cross multiplication or cross products. So we take one numerator and multiply the other denominator, and I do not know my multiples of 11.4. So I'm going to show some multiplication here. So we get 68.4, and I'm going to actually show this through dimensional analysis. Inches times feet, because that's an inch times a foot. I just want to constantly show how dimensional analysis doesn't fall apart. It still is recycled, but as math students, we tend to think of only numbers, not the units. So now we have to do the other cross product, which is 1" times x feet, and that's going to end up with x inches times feet. Wait, we don't know about the feet yet, so that unit actually won't be here right now. Okay, so, and then also remember the equal sign does not disappear. It is still there. Well, it looks like we have 68.4 inches per foot, or times feet, equals x inches. We don't want inches on this unit anymore. Sorry, it does have feet. So we're going to divide by inches over here, and divide by inches here. And it turns out 68.4 feet is the exact length of our variable that we need. So this skateboard's ramp will have to be 68.4 feet long for us to build it. And I'm going to write out that answer for us. The skateboard length that would be a really large skateboard. The skateboard ramp's length will be 68.4 feet. So we're using that skill of cross products. Okay, going on to problem 5 here. Example 2, slide 5. I'm going to ask you to pause and copy down what you see. Okay, welcome back. Okay, so we're reading our problem here, and again, we want to remain consistent. And since I did the first problem with model on top and actual on the bottom, I'm going to demonstrate that it doesn't matter where it goes, top or bottom, but as long as we're fair from left side of the equal sign to right side of the equal sign. So this time I'm going to model it as putting the actual numbers on the top and the model numbers on the bottom. So let's read through this problem here. We got World War II, Washington, D.C. is 17 feet tall. A scale model of the memorial has pillars that are 5 inches tall. What is the scale of the model? How do we figure this out? Can we create a cross product or a proportion for this problem? So let's see. We're going to have actual on the top. So we know that the actual number of this thing is 17 feet. And the model is 5 inches tall for that same pillar. Well, when we have a scale, normally one of the numbers is a 1. So let's actually assume about 1" is what we're going to have there. And we do not actually know how large this scale is converting that 1" into. So now we're going to use our cross products here. We get 5x equals 17. And to get the x by itself, we have to divide both sides by 5. And 5 goes into 17 just because decimals are usually better when measuring things. And we get 3.4. So what we've actually discovered is the scale. And again, like I said, scales usually use a single unit rate somehow. So we were able to infer this 1 inch being used. So let's write our answer here. The scale of the model is for every 1 inch, there are 3.4. What's that unit on the actual model? Yeah, you're right. Feet. So that is how this artist created their model. For every 1 inch, they realized that is going to be 3.4 feet on the actual building. Okay, so we have one more example here. And this question is going to ask us to find the scale factor. And really, that's actually what we kind of just did here, and I'm going to show it just a different way. You may have noticed on this problem over here that all we actually had to do was divide 17 by 5 to get that 3.4. But I wanted to demonstrate the cross products or proportion being used. We can also do it by making these ordered pairs into unit rates. So let's actually model that way. So this problem wants to find the scale factor, and it could be done through a proportion like I just showed, but we can also do it another way by creating unit rates. So we're going to just have to be consistent. So I'm going to do sculpture over model. And every time I do my unit rate, I have to make sure to put sculpture's info on top and models on the bottom, or else we would get a very funny looking answer. So let's find out what this artist did for their scale factor. So we're going to find out. Let's do the length problem first. And to do the length problem, it's going to be 70 feet divided by 7 feet. And we're going to convert that. They have a 7 in common, and that turns out to be 10 over 1. So for every 1 foot in the model, it represented 10 feet in the actual sculpture. Or they scaled it up by 10. But we're not sure about that yet. We have to prove that this artist maintained the same thing for all of their dimensions. So let's make sure the width also follows that. So we got 50 feet over 5 feet. They have a 5 in common, and yep, what do you know? This artist was smart and consistently kept the same scale of multiplying it by 10. And you may be noticing that feet divided by feet is actually the number 1, so the scale factor for this problem would just be the number 10. But let's try one more. We got to make sure that this height also maintains the same scale. And we got our height, it's going to be 60 feet over 6 feet. They have a 6, we're going to make that unit rate. We got 10 feet over 1 foot, and again, that means the scale factor is the number 10. And we can actually represent this better. We're kind of writing it out in a sentence. So what you would want to write here is the sculptor, someone who makes sculptures, scaled the model up by a factor of 10 to create the sculpture. Or you could just write the sentence, the scale factor the artist used was 10. I like how you kind of relate that the model is scaled up by 10 to get to the actual sculpture. If you're confused on this at all, please write some questions in the question column of our notes here, and I will be back to answer more questions after. I hope everyone's doing well. I'll see you soon.